Welcome everyone. We want to do a short demo of some first-time testing we did at EANTC. It is surrounding what is called PCEP Association Group objects. And I'm here accompanied by my colleague Diego from Nokia and Christoph from Juniper. What is a PCEP Association Group object? It's really an object that allows me to identify a relationship between LSPs or a relationship between attributes and an LSP. Now, this has some useful use cases for it. We'll cover that in the next slide. There are multiple types of association types in PCEP. One of them is called the SR policy association type. That is the object that allows me to signal attributes such as color and preference of an SR policy. You also have the disjoint association type. That it allows me to specify two LSPs to be disjointed. We have the policy association type for some attributes, and we have bidirectional and path protection association type. If you look at the slide, we can see where the action is happening at EANTC, and in particular in this demo, we're going to discuss the disjoint association type. The use case for that is creating LSPs, for example, that have diversity. So LSP1, one path, LSP2, another path. Here there are some details on the exchange of messaging, but all you need to remember is if you look at a head end, like a router on the left, is that you can have two LSPs that initiate on that PCC on the left, and it's looking for computation delegation to the PCE, and the two LSPs are going to be part of the same association, disjoint association group, in this case association ID 1, and they're going to be computed for link diversity, as being shown on the slide. Similarly, you have the link association type disjointness from the right. We're using different messages. You have a PC request, reply, exchange, response on the left, and you have a PC report update on the right, on the left-hand side. Regardless, it's the same object. So with that, we want to show you what happened at EANTC, and Diego will cover this.
Thanks, Jose. Thank you very much. Welcome, everybody. My name is Diego, and as Jose was saying, I work for Nokia. Thank you very much to Jose and Christoph for helping in this demo, right? So as Jose was saying, so the results we have at the EANTC, we tested with a mix of PCEs and PCCs. So we had Nokia NSP and Cisco CNC as PCEs, and we also used Nokia PCC and Juniper PCC, and also a Cisco PCC in this case. So as you can see in this slide, the results were satisfying between this mix of vendors in both PCC and PCE rows. And particularly here in this demo, you can see in these two screen captures that we have, this comes from Cisco CNC as a PCE for this particular test case, where you can see on the image on the left, you can see a couple of SRT LSPs or SR policies. These association groups can be applied to either SRT LSPs, SR policies, either with MPLS and or SRv6 data planes, right? So everything is the same in this case. So we have a set of disjoint LSPs from the Juniper PCC that ends on the Nokia PCC in the upper left section of the topology, and in the other image to the right in this slide, we have a couple of SR policies disjoint also that go from Nokia PE, from the Nokia PE on the upper left portion in the network to the Juniper PE on the left down corner in this topology. Okay, so what we also have here for this demo is actually, well, we actually have a live demo now where we are using NSP as the PCC, and we are using both Juniper PCC, Nokia as a PCE, and both Juniper and Cisco as PCCs. So this is the topology that we have here. There is a lot going on behind, right? So this topology is acquired via BGPLS, so there is an object of interop in this case particularly. So we also have a list of LSPs. So as you can see, for example, on the Cisco case, we have this policy first, and you can see the path is taking from the Cisco device down to the Juniper device down here, and we can see the path, and we can see the association type. So the association type in this case, or the association group in this case, sorry, it signals the association ID, which in this case is 666, and it also signals the association type, and more importantly, the diversity type. As Jose was mentioning, we have multiple diversity types or disjointness types. In this case, we are using link, but we also support node, and we also support SRLG disjointness, and we support a mix of link and node, on the node and SRLG, and link and SRLG too, okay? So what we are going to do now, so we have a single policy here, and now Jose, thanks Jose, he's going to enable the second SR policy from his PCC towards the destination PCC. And you can see here we have the first one, and down here is going, at some point in time, we're going to have the second policy. Let me just refresh this. No, we don't have it. So, yeah. So we only have one. So we should be having two policies. Okay. So in the meantime, so what we are going to do also with Juniper. So with Juniper we have a single policy in this case. So as you can see, it goes from Juniper MX204 to Cisco H47. Okay. So now Christoph is going to be enabling the second one right here. So we will see Cisco 4701. At some point in time, we will have Cisco 4702, okay? So let me just, yeah, there you go. And if we select them, just a second, you can see there that we have two diverse LSPs, right? So they are both going from MX204 to Cisco H47, and you can see they are linked disjoint in this case, right? So, and as you can see here, let me show you again a few details. You can see the association group for each of these policies. So as you can see, they use the same association ID. So let me show you that. So association ID and association diversity type, okay? So 2001 and link. But if we see the other LSP, we can also see the same information. So as Jose was saying before, they have to share. When a couple of LSPs are grouped together using association groups, they have to share the same association ID, and also in this case, the same association type and the same disjointness type. So in this case, a PCE is capable of grouping those LSPs and also computing diverse paths as required. Okay. Okay.
I think I made a typo.
Perfect. Thank you. So as we were saying before, we should be having we should be having two SR policies from the Cisco PCC. So as you can see, at the beginning we had one, and now we have the second one. So again, let me just select them.
It was my bad.
Yeah. Thanks. Or it may have in the Nokia PCE too, so you never know. So as you can see, as we were saying before, we have a couple of SR policies in this case, because on the Cisco PCC there are SR policies. And you can see that we have a disjoint path for each of them. And let me show you quickly here the association information. As we were saying before, we have the association ID and the association disjoint or diversity type, which is set to link, okay? And we have the same parameters in both LSPs. And as I was saying before, thanks to these parameters that we have here and that are signaled using the Path Computation Element Protocol, PCE is capable of grouping these LSPs and computing diverse paths, in this case with the constraint of being link diverse, okay? So I think that's it. I don't know if Jose, Christoph want to add anything else. Thank you very much for being here today. Thanks.
Thank you very much, Diego. So I think this is a very interesting test area, because we see a couple of vendors really deeply involved and very innovative.